Hello, this is Mr. Win, and today's video will be about common logarithms. So remember, all logs have a base. Now the most common base is base 10. Since it's used so much, it's the default log in the calculator. And if you don't see a base next to the word log, it's automatically an invisible 10. So here's what I mean. In the calculator, we have been using math and going to log base. However, there's log right here next to 7. If I press that to log, you don't see a log base next to it. So remember, let me do this real fast, math. If you have a log base to the same number, they cancel out to 1. So if I just do log of 10, it cancels to 1, because remember, there's an invisible 10 right there. There's the graph. Again, these are the same thing. If it doesn't have the number in the base, it's automatically 10. And here's some things on the bottom. Basically, if you exponentiate both sides by 10, say I did 10 to the power 10 both sides, that cancels. I have x equals 10 to the y. They wrote it backwards, that's fine. Log, if I extend both sides here, that cancels. 1 is 10 to the 0. Y'all know anything to the 0 power is 1. Same thing here, 10 to the 10, well that cancels. 10 is 10 to the first power. And that last one, exponentiate, I get 10 to the m equals 10 to the m. All right, so those things are true. It's just the exponentiating rule that we've been doing. All right, example 1, solve for x, round to the nearest 10,000th. So first let me solve it their way. We're trying to get x down, so to log both sides. Now I'm going to do log base 10. All right, so there's log base 10. I'm not going to write the 10. Now we can bring the exponent down. So this is x times log 4 equals log 19. Now log of 4 is just a number, it's a decimal. So I can divide by that. All right, so that cancels. I have x equals that log, whatever that is, log 19 divided by log 4. That is the answer. Now they want decimal, so let me put in the calculator. So it's a fraction. Log 19 on top. On the bottom, log 4. I can't do anything to fix this. It gives me 2.12 10,000ths, tenths, hundredths. 4 decimal places, all right. So 1240, 2.1240. So that's about 2.1240. All right, so I saw that using the common logs. Now, this is technically inefficient because I showed y'all the better way before. I tried to take the smart log of the base. So I'm going to basically log, let me go down a step. I'm going to log base 4, both of them. Remember, when you have log of a base with the same number, it cancels out to 1. So this is really gone. So I have x equals log 419. This is the same answer on the other side. So the answer is a lot cleaner. You only have the word log once. So I do math, log base 419. You get the same answer, see, 2.1240. So the left side's common logarithms. Use that if we don't have a calculator, if we can't change the base. You just want base 10. But I like the right side better. All right, so since they're the same thing, these two things are the same. That is actually another thing. It's called the change of base formula. All right, if you have this thing right here, you can rewrite it as this thing. All right, whatever that number is goes on top, whatever the base is goes on bottom, and you pick any other base in between. So here's my quick example. Log base 450 is the same thing as log base something of 50 divided by log base something of 4. Anything can go to that number spot. It could be a 10 if it's common logarithms. It could be a 37. It could be pi. It could be any number you want. So example 2, express log base 3 of 20 in terms of common logarithms. They want log base 10. Then round your to the nearest 10,000th, 4 decimal places. So following that formula, this I'm going to break up to 2 logs. Log of 20 on top divided by log of 3 on bottom. Remember, I don't have to put the 10 there, but I could put a 20 there, 23 there, whatever I want, but that is the answer. Log of 20 divided by log of 3. They want the decimal 4 places, so again, a fraction. Log of 20 divided by log of 3 gives me 2.7268. The 8 does not round up, so 2.7268. 2.7268. That's the decimal approximation. All right. Now here's the hardest one. Solve for y, then round the answer to the nearest 10,000th. All right, here they want to do common logs, but I'm going to tell you just do it our way so we can get things to cancel out. First, I'm going to get the y's down, their exponents, so I'm going to log base 3 both sides. Log base 3 both sides. All right, once you log, this cancels, exponent goes to the front. Exponent goes to the front. So this left side is just 5y, so that's easy to work with. This right side is a little difficult. This is in front, in parentheses really, of log base 3 of 7. On the right side, I need to distribute. So I distribute this and that. So the left side is this. The right side is y times log base 3 of 7 minus 2 log base 3 of 7. I need to get y on one side, so I can subtract y log 3 of 7 both sides. All right, so I'm at 5y minus y log 3 of 7 is less than negative 2 log 3 of 7. Now on this left side, see I have a number times y minus, basically it's another number. I don't know, maybe I'll say 8. I don't want to say that. All right, log is this number, so let me call this y. Let me just make up a number root 3. All right, there's a GCF between these two. All right, I'm not going to remember the number, but the letter. Y is in both, so I can take out a y, and whatever be inside be 5 minus is root 3. So I can take out a y out, undistribute, GCF really. I'm going to do that right here. So I take out a y. What's left is 5 minus log 3 of 7, less than negative 2 log 3 of 7. And the last thing is to solve for y, I got to divide by this 5 minus log 3 of 7 on both sides. Log 3 of 7. This is gone. That's my answer. All right, so I'm going to this corner. Y is less than, on top is negative 2 log 3 of 7. On bottom is 5 minus log base 3 of 7. All right, if you did it like this is the shortest and fastest way. If you did common logarithms, you'd have the word log 2 more times, so 4 times total, and it'd look really messy. Now they want the decimal, so let's do that. Fraction. On top is negative 2 log base, so math, log base 3 of 7. On the bottom is 5 minus log base 3 of 7. This decimal is negative 1.0972 because that 6 bumps that 1 up. 0972. 0972. All right, there's my answer. One is the exact answer, one is the decimal approximation. All right, here's your practice problem. Change that with common logs. If you can do that, you should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.